Voronoi diagram. So let's say we've got an existing Voronoi diagram with the sites A, B and C. We've got the vertice or the vertex because there's only one vertex here and the edges separating them. We're going to add D to the diagram. Now because D is in the cell with B, it's going to affect B, and because it's next to the cell with A, it's going to affect A. It won't affect anything else to do with C though. So this means we have to work out the perpendicular bisector between A and D and B, and this is how we do it. The first thing you're going to do is you are going to calculate the perpendicular bisector between B and D. You would do this mathematically like we have done in class and on the videos. You'd then work out the perpendicular bisector between A and D. And what you would then do is you'd get rid of this excess line because we've now formed two vertices. We've got two vertices here. We've got a vertex which A, D and B are close to, and then we've got a vertex which A, C and B are close to. Now they could ask you a specific question about this, and I'll explain what question they could ask you. And they could ask you for the largest empty circle. And what we mean by that is if we select this point in the middle, and then we select the B, the D and the A, we can work out the distance from this vertex to either A, D or B. And this is going to give us a particular distance. Now, if we repeat that process, but this time for this vertex, and this time this vertex is close to not A, D and B, it's close to C, B and A. What you need to do is you need to work out either one of these three straight lines between A and vertex, D and vertex or B and vertex, calculate just one of the lengths of those lines using the distance formula, and then you have to work out one of the lengths of the lines from star to C, star to B, star to A, and then you need to compare. You compare this one length of line with this one length of line and you see which one is the biggest. And if it's asking you for the largest empty circle, you will choose the vertex which generates the largest empty circle. Now, we could do this in practice. Let's have a go at doing this briefly. If we're going to do this question in practice, let's take this onto a PowerPoint slide and talk through it step by step. The distance formula then. Let's talk about the distance between the vertex and then one of the points closest to it. So let's talk about this distance here. Now, in order to calculate this, it's a bit like applying Pythagoras. You can either use coordinates or you can do it visually. So what you're going to do is you would do 1 squared plus 3 squared. So the answer is going to be the square root of 10. So the distance between this vertex and all the points closest to it is the square root of 10. Now let's do this for this vertex at the bottom and all the points this is closest to. So A, C and B. And we can do it again with A, but let's do it for B so it's clearer on the screen. We're going to do 3 and 1. And you can see again, by chance, we have both vertices being equidistant from their chosen 3 points. So star is equidistant from A, C and B, and it's exactly the same distance that this vertex is from A, D and B. But in the exam you might get one of these answers being bigger, and this will be called the largest empty circle, or the largest distance. Last but not least, we're going to talk about adding a vertex and how this happens when we add a site. But rather than adding a site on the outside like we did in this question, and it didn't have much of an effect on the diagram, we're going to add a site right in the middle. Now, if you add a site right in the middle, it affects everything in the diagram because E is in cell with D, it's close to the cell with A, it's diagonally opposite the cell with B, and it's close with the cell of C. So it's going to affect absolutely everything. So you have to calculate lots of new bisectors. ED bisector, AE bisector. You need to calculate BE bisector, and then you need to calculate EC bisector. Then you're going to leave in the original lines on the outside, but you're going to get rid of all the intersecting lines in the middle. We do not need this, and this will be our new Voronoi site. So now we've got 5 cells rather than 4. I hope that's helped you in understanding Voronoi.